Hello, and welcome to the Cognitive Edge. I'm Dr. Daniel A. Sable, and today we will be talking about teaching students actual programming, and not as a specialized subject, but reserved for future computer scientists, but as a practical form of literacy that can really help students become stronger thinkers, problem solvers, and creators. Um, When many educators hear the word programming, I think they immediately imagine complicated mathematics and endless lines of code and students sitting silently in front of computers. That's not the case. It's imagined, and that can make programming feel more intimidating. But um, for you teachers out there, you guys are strong, and our librarians are strong. um, so, you would have to put up with and then grow a little technical background to understand it. Um, but the beginner programmer does not have to begin with complicated code. It begins with a much simpler idea, which is teaching students how to give clear instructions, how to recognize patterns, breaking large problems into much smaller steps, to test possible solutions and really learn from mistakes, which is the biggest one. In many ways, educators already teach the foundations of programming every day. When students follow the steps of an experiment, um, organize information into categories, identify the sequence of events in a story, or revise a piece of writing, they're practicing skills that programmers use. Programmers simply place those thinking skills into a digital environment where students can immediately see the results of their decision. So, programming is definitely a way of thinking. Um, the most important lesson that students should be taken away is can learn from programming is not really how to memorize commands. It is how to think through a problem. Imagine that a student wants a character on a screen to move across the room. Collect an object and then return to its starting point. The student must decide what the character should do first, what should happen next, and what condition may change the character's behavior. This process requires sequencing. The student may need to repeat an action several times, which that introduces the concept of a loop. Um, the character may act differently depending on whether it touches an object or reaches a wall. That introduces conditional thinking. If this happens, then do that. The concept may sound technical, but students already encounter them in really everyday life. Um, if it is raining, basically take an umbrella. Um, Repeat the exercises 10 times if you have to. Do it 12 times. Follow the recipe in the correct order. That's always very important. Check whether the answer is reasonable before submitting it. You always want to just look at your work, even though it's hard, um, because you think you maybe made a mistake, but um, um, always give it a shot. Programming really gives the student, a formal way to practice this kind of logical thinking. And I would actually begin without a computer. One of the best ways to introduce programming is to begin with unplugged activities. An unplugged activity teaches programming concept without requiring a computer or device. Um, this helps students focus on the thinking process rather than becoming distracted by software, passwords, or technical problems. A teacher or librarian might ask one student to act as a robot while another student gives instructions. The instructions must be precise. Um, Walk over there is not precise enough. The student may need to say, take 3 steps forward, then turn right. Take 2 steps forward, pick up the book. This is, um, more of an algorithm that, the computer would be looking for. So if the robot ends up in the wrong place, the class must examine the instructions and determine where the error occurred. The activity introduces algorithms, which are simply step-by-step instructions for completing a task. It also demonstrates one of the most important principles of programming. Computers do not exactly do what they are told to, not necessarily what the programmer intended. That difference also creates the bugs that students must learn to find and correct. Um, that's a difficult piece of the job, and securing up and shoring up the networks and so forth, everything is just, is needed. Another unplugged activity involves writing instructions for making a sandwich, tying a shoe, checking out a library book, or finding a specific title on the shelf. Students quickly discover that tasks they consider simple actually contain many smaller steps. Programming teaches them to notice those hidden little steps. Um, Moving back into block-based coding for a moment. Once students understand sequencing and instructions, block-based coding is an excellent next step. Programs such as Scratch and Scratch Junior allow students to drag and connect visual blocks rather than typing every command. Different blocks control different movements, sounds, appearances, timing, repetition, and decision making. Um, Block-based coding really removes many of the frustrations that beginners experience when they misspell a command or forget a symbol. Instead, students can concentrate on the structure and logic of the program. Um, a student might begin by making a character move 10 steps. Okay. Next, the student might add a sound or a little noise pocket. Um, then the student could make the character speak, change direction, or respond when clicked. These small accomplishments matter. Students need to see that their choices can provide visible results that give immediate feedback and really builds confidence and encourages experimentation. However, the goal should not be to rush students through a list of commands. The goal really is to help them understand why the program behaves the way it does, why the compiler compiles, why the code is in the structure it's in. Educators should regularly ask questions such as, what do you predict will happen when we run this program? So that's again with the compiler. Why did the character stop? What put an end to the run? or to the command. What would happen if we changed this number? Um, can you find a shorter way to create the same results? These questions, they turn coding from a button clicking activity into a thinking activity. Um, a big problem in coding is the many concepts that are provided at one time. It's our business to teach one concept at a time. Students, they really can become overwhelmed when they are introduced to too many programming concepts at once. Um, so begin with sequence, help students understand that commands are carried out in a particular order. Um, and then basically introduce events. An event is something that causes a program to begin or respond. A program may start with a green flag is clicked, or when a key is pressed, or when two objects are touched. After that, you probably want to introduce loops. Loops, they actually allow a program to repeat an action without writing the same instructions over and over and over again. Students might use a loop to make a character walk continuously, repeat a sound, or create a pattern. Um, so, conditional statements, what are they? Um, conditional statements, they allow for the program to make a decision. For example, if the character touches the edge of the screen, it may turn around. If the player answers correctly, the score increases. Variables can really be introduced later, but a variable stores information that may change, such as a score, a timer, a player's name, or number of lives. Um, each new concept should be connected to something students already understand. Um, so a loop is like repeating the chorus of a song. And a condition is like deciding whether to wear a coat based on the temperature. Um, and a variable is like a labeled container that holds information. So you have the three, and we try to, given concrete comparisons, make abstract concepts easier to understand. Um, and I'm a big believer in just letting students create meaningful projects. Um, Programming becomes more powerful when students use it to express an idea rather than merely complete disconnected exercises. Teachers and librarians can connect coding projects to almost any subject, but students can animate a scene from a book, or create an interactive book review, or design a quiz about a historical event, model the weather cycle, demonstrate a mathematical concept, or even create a digital tour of the library. Um, a student studying ecosystems might program different animals to respond to change in their environments. Whereas if you have a student learning vocabulary, they may create an interactive matching game. Um, when you think of things as the ed tech person, you're going to always be thinking of a variety of different things, not just, you know, whatever, but the most important is, does the game help? So a student reading a novel night animated and important scene and really explains the characters. A student studying local history might build a digital timeline with clickable events. And these projects will really help students understand that programming is not separate from the curriculum. It is a tool for communicating knowledge. The strongest project usually combine coding with storytelling, research, design, collaboration, and reflection. The role of the librarian in this whole thing are especially well positioned to support programming instruction. Libraries have always helped students locate information, evaluate sources, organize ideas, and to really create knowledge and become knowledge managers. Programming extended that mission. A school library can become a place where students can explore coding through clubs, maker spaces, classroom collaborations, research, um, and really independent learning. Librarians can curate beginner friendly programming resources, help teachers locate appropriate tools, and design projects that connect coding to books and to information literacy. Um, I always tend to find that, um, after reading a story, students they may program an alternative ending. They might create an interactive character map, um, or they may design a game based on the challenges faced by the main character. So, um, really, what is the protagonist and the antagonist doing in the story? And can you rewrite them with code? It's pretty cool. Um, Students could research an important person and create a digital presentation that allows users to explore different parts of that person's life. Programming also gives librarians an opportunity to teach digital citizenship. Students they really can discuss copyright and responsible sharing, online collaboration, accessibility, and the ethical use of technology. The library should not merely be a place where students consume digital information. It should be a place where they learn to create it responsibly. We really also want to normalize mistakes and debugging. One of the greatest educational benefits of programming is that mistakes become part of the learning process. They lie there and wait for the student to come along and find them. And it's a program rarely works perfectly the first time. Um, it may take forever, but professional programmers they do make mistakes constantly. They test their work. Um, they examine the results. They identify the problem, and then they revise the code. Students really need to understand that a bug is not evidence that they are bad at programming. It's evidence that they are programming. The educator's response to errors matter. Instead of immediately fixing the problem, we as educators should ask the students to explain what the program was supposed to do and what it actually did. And you'll see, you'll get all different kinds of answers. Then help the students examine the code one section at a time. And the questions may include something like where does the problem begin? Which command controls this um, action? And, what can we temporarily remove to test the program? Really, programs, they need to really receive the help that the event it was waiting for ultimately. If the conditions ever become true, this process develops persistent um, and metacognition, and students begin to think about their own thinking. They learn that confusion is not a signal to stop, it's a signal to investigate. It's really a positive way to think. Um, you want to avoid taking over the keyboard, so adults often want to help students by fixing the code for them, but really we're not going in the right way. That does solve the problem immediately, but can it also remove the most valuable part of the learning experience, which is that's the teachable moment that you're in right there. Um, when educators take over the keyboard, students become spectators, and that's kind of not what we're looking for. A better approach is to provide hints, ask questions, or really try to point students toward the relevant section of the program. Um, the students should really remain in control whenever possible. Um, they should never be having any type of um, control issues. Even when the solution seems obvious to the educator, the student needs the opportunity to discover it. Programming instruction should follow a simple principle: guide the thinking without stealing the thinking. So let's guide the thinking without stealing the thinking. We really, as educators, want to encourage collaboration. Programming is often presented as an individual activity, but professional software development is extremely highly collaborative. Students should really have opportunities to work together to discuss ideas, explain their reasoning, and test one's against another's program. Pair programming is one useful strategy. Um, and it's so important that everybody becomes specialists with Scrum and with different foundational resources that help with this, work in different groups and so forth. But in pair programming, two students work together at one computer. One student controls the keyboard and mouse while the other student reviews the plan, notices errors, and suggests improvements. Those students then switch their roles. This structure encourages communication and reduces the belief that the fastest student is automatically the strongest programmer. Students can also participate in gallery walks where they explore one another's projects and provide feedback. Feedback should go beyond saying that project is good or bad. Um, it really needs to, um, have students really identify one feature that seems to have worked well and one part that was confusing and one possible improvement. Explaining a program to another person often reveals gaps in understanding. If students cannot explain how their code works, they may not have copied a solution without fully understanding it. Um, Providing structure without limiting creativity um, really beginning programmers need clear examples and manageable challenges. With that being said, we need a completely open assignment, such as, creating anything you want, can be overwhelming. Students may have too many choices and no clear starting point. Um, Educators can provide a structured challenge with room for creativity. For example, um, some of those ideas are to create a short animation with two characters. Um, they would include a dialogue. They would also use at least one loop. Um, they would use an event that allows the viewer to interact with the project. Students, they're working within common requirements, but they can choose the characters, settings, stories, and design if they're able to maintain and keep up with that. Um, but the balance really helps educators assess specific programming skills while still allowing students to develop original ideas. Um, we also really want to make programming accessible. Programming instruction must be designed so that all students can participate. Um, Students may differ in reading and their ability, their language proficiency, their motor skills, attention, confidence, prior experience, and access to technology. They all come into play in a major way. So, directions, they really should be available in multiple formats. Educators can combine written instruction with demonstrations, screenshots, visual examples, and verbal explanations. Projects should be broken into smaller stages so they're nice and easy for our students. Students should be allowed to demonstrate understanding in different ways. Um, this happens to be one of them. Some students may benefit from starter code, others may need extra challenges, others may dislike it completely. Keyboard shortcuts, speech to text, um, enlarged displays, captions, and accessible devices may help students participate more independently. It's also important to avoid assumptions about who will be good at programming. Um, Students do not need to be advanced in mathematics to begin coding in any way. Um, they do not really need to own a computer at home or uh, be stuck to electronics at home. They don't need to fit the stereotype of a computer person. Programming really should be presented as something that belongs to everyone. It's not just for certain people. Focus on understanding and not speed. Some students will complete coding activities quick. Others will need more time. It's just, it happens. Speed should not become the main measure of success. Really, it should be, um, a student who finishes first may not understand the code deeply, where a student who struggles for 20 minutes and eventually identifies a bug may have learned far more. So, assessment should examine the student's thinking process. Can the students explain the sequence of the program? Um, do they really get, um, and can they identify where repetition occurs? Um, can the students describe the condition that controls a decision? Can the student revise the program after receiving feedback? Can the students explain what was difficult and how the difficulty was addressed? I'm sure that everybody hits a snag or hits something that makes it difficult. It never fails. And the finished project matters, but the reason behind it matters more. So, last here is going to be helping students move beyond copying. Tutorials are useful for beginners, but students can become dependent on following directions step by step. A student may successfully copy a program without understanding how it works. So, after students complete a guided tutorial, ask them to modify the project. Um, they might change the characters or add a new level or redesign the scoring system, create different um, endings, or introduce a new condition. Um, we um, know that modification forces students to make decisions. And we know that making decisions, um, eventually students, they should move from copying a project to remixing it and finally to creating something original. Um, and each student should be able to walk through that. The gradual release, it builds independence. Um, being introduced to text-based programming carefully after you guys develop confidence with block-based coding. Some may be ready to explore a text-based language such as Python. Um, and now you really get moving into the big league, so to speak. The transition not be presented as abandoning beginner tools for real programming. Block-based coding is real programming because students are still working with sequence, logic, events, loops, variables, and conditions. Um, nothing is different about it. Um, text-based coding projects introduce syntax, which really means students must type commands using the correct structure. A simple Python activity might ask the computer to display a message. Like you see here, it says print hello world. Students could then create variables such as like name equals Jordan, um, print hello plus name, and then they may later write a simple conditional that is ultimately going to get the student's age. And here it is 12. If the age is greater than 10, you may join the coding club. The purpose is not to move quickly into complex programming. The purpose is to help students recognize that the same concepts they've learned with blocks also appear in text-based languages. You just have to keep your eye out for them. The surface changes, but the thinking remains the same. The educator really does not need every answer. Teachers and librarians, they sometimes hesitate to teach programming because they fear students will ask questions they cannot answer. That will happen, and it does happen occasionally. It's okay, it happens. Technology changes quickly, and students often experiment in unexpected ways. Educators really do not need to know every answer before beginning. It's a different world, and they need to model how to respond when the answer is unknown. An educator can say, I'm not sure. Let's examine the code and then test some possible solutions. Or look for reliable information. Maybe there's something out there that will help. And that's not a weakness. It demonstrates intellectual honesty, researchability, and persistence. In programming, the educator does not always have to be the expert developing solutions. The educator can be the facilitator who helps students investigate problems and, um, watches them through a simple first lesson. Like a strong first programming lesson can be surprisingly simple. So I would begin by explaining that a program is is a set of instructions given to a computer. Ask students to write instructions for moving a classmate from one side of the room to the other. The students would then test the instructions, like literally. And what would happen was the students would discuss what was unclear or missing. And they really think or power through this. They introduced a block-based environment, coding environment. They show students how to select a character and make it move. You allow them to experiment for several minutes. You don't want to just rip them off after you put them on. Next, you give them one clear challenge. Make the character move, speak, and return to its starting position. We're going to bring this class together and ask students to share different solutions. And some students may use several movement blocks. Others may use a loop. Some may discover a more efficient approach. But, that is really the end. You want to then ask students to reflect and basically, what did they want their computer program to do, and what problems did you encounter? How did you solve it? You keep some of these questions in the back of your head, like, what would you add next? And so, it's hard for me, um, because things keep running through my head. So I just want to say thanks for joining me. It's Dr. Daniel Sable. And what I'll say is teaching students programming is not simply about preparing them for technology careers. Um, it's about giving them another language for thinking and creating. And programming teaches students to really break down complicated problems, test ideas, recognize patterns, respond to feedback, and persist when their first attempt fails. It gives the students the opportunity to move from um, being passive users of technology to active creators of technology. Teachers and librarians do not need expensive equipment or advanced degrees in computer science or perfect technical knowledge to begin. Um, you just get your feet wet. You're going to have a willingness to learn and a curiosity, and you're going to start small, and then you're going to work your way out. All right. So it was lovely having everybody here. Again, Dr. Daniel Seal, thanks for watching the Cognitive Edge. Have a good day. Bye bye.